In this video, we're going to address a topic that terrifies flat earthers because it provides irrefutable evidence that we do live on a globe. We're going to look at real aircraft flight plans and prove that they are calculated for a globe. This is 100% verifiable, testable, and repeatable. We're not going to use crayon drawings as we see on flat earth channels. We're going to use a real aircraft flight plan, and this is one between Santiago in Chile and Christchurch, New Zealand for a Global Express corporate jet aircraft, the same type that I fly. In this flight plan, you will see waypoints, which are also called checkpoints, the location of each checkpoint, the course between checkpoints, and the distance between checkpoints. And we're going to look at the mathematics that can prove that these distances are in fact computed for a ball. And I'm sure some of you have already seen this formula because it has appeared many times in my comments replying to flat earthers. It is a formula that calculates the great circle distance between any 2 points on a sphere, and it works by determining the angle between the 2 points and then multiplying it by the radius of the sphere. On a number of occasions, I have posted this formula, challenging flat earthers to debunk it by finding any location on Earth where it does not calculate an accurate distance. And of course, they have been unable to do so. And as you can see in this formula, we have the number 6371. That simply tells the formula how big the ball is. The first part of the formula does not care about the size of the ball. It simply calculates an angle in radians between 2 points on the surface. And the advantage of using radians is because when this angle is 1 radian, the distance between point B and C on the surface will be equal to the radius of the ball. So if the ball had a radius of 1 meter and the angle between B and C measured from the center of the ball was 1 radian, the distance between B and C would also be 1 meter. And that is what the first part of the formula does for us. And so once the formula determines the angle between the 2 points on the surface of the sphere, we multiply that by the actual radius of the ball. In this case, we're using 6371, and the unit is kilometers, because we know the radius of the Earth is 6,371 kilometers. And by using the real radius of the Earth, the formula is going to calculate accurate distances across the surface of the Earth. Now remember, flat earthers, if the Earth was flat, this formula would not work at all. It would produce nonsense. If the true radius of the Earth was not 6,371 kilometers, the formula would also produce nonsense. The distances that it calculates would not match reality. If we change this number to 7,000, the distances would be too great. If we change the number to 5,000, the distances would be too small. But if we set the number to 6371, as Goldilocks would say, the results are just right. And I realize at this point, flat earthers are going to jump up and cry, "Wait a minute, you are making an assumption that the radius of the Earth is 6371 kilometers. But consider this, by using that number in this formula and telling the formula that the ball has a radius of 6,371 kilometers, it is able to accurately calculate distances on the real Earth between city blocks, between airports in different states, and even between different continents. If the Earth was flat, or the radius of the Earth was not 6,371 kilometers, this formula simply would not work. Now, as you're about to see, we don't have to just assume the radius of the Earth is 6371 kilometres. We can calculate this quite accurately for ourselves, and in a future video I'm going to show you how you can do that using an equatorial telescope mount and arrive at a very precise figure that matches that perfectly. However, for now I'm going to direct you to another video made recently by Olivier Joseph, and I will post the link in the description below, who uses some of the footage from my aircraft that accurately measures the amount of horizon drop from high altitude. And by using that data, he was able to determine quite accurately the radius of the real Earth. I won't play the video. I recommend you go and have a look, subscribe to his channel, because he covers it in very good detail. You will see just how easy it is to confirm the radius of the Earth for ourselves. So let's now use this formula with a value of 6371 kilometers for the radius of the ball to calculate distances between waypoints on our real flight plan and see if the results match the distances published in the flight plan. I realise it is quite long-handed to do that with a calculator, so to speed up the process, I have produced this simple Great Circle distance calculator using Excel. We only need to input the latitude and longitude for the first location and the second location, and the spreadsheet will do the rest. It will calculate distances in kilometers, statute miles, and nautical miles. And the formula that we've been looking at here is contained in cell C10, and you can see it very clearly up the top here. So here's our flight plan. Let's now calculate the distance between two waypoints and see if the result matches what the flight plan shows. I could use any two waypoints on this flight plan because every one of them has the exact location listed. I have just chosen two random points in the middle of the ocean. The first one, 53W50, and the second one, 50W60. The location, south 53 degrees latitude, west 150 degrees longitude. Let's put that in. South 53 and west 150. And the second waypoint, south 50 degrees latitude, west 160. And the flight plan is showing us a distance of 414 nautical miles. Let's see if the calculator agrees. So we want south 50 and west 160. And there we see very accurately it has shown us the distance in nautical miles is 414. That matches perfectly to the actual flight plan. And I will post a link to this flight plan. Please feel free to test the distance between any points on this flight plan yourself, and you will see that they always match the calculation based on a ball with a radius of 6,371 kilometers. In addition to verifying the distances on a flight plan, we can also do the same thing with long-range international flight charts. This is the Indian Ocean orientation chart produced by Jeppesen, and as you can see, there are literally hundreds of waypoints listed on the chart with the tracks and distances between each waypoint. We could select any two pairs on this chart or any other IFR chart and test it with our small calculator, and you will see that the distances always match the distance computed for a ball 6,371 kilometers radius. Let's pick a sample. We've got IBMAT and EPMOL. So let's have a look at what the chart is telling us as a distance, 439 nautical miles. Let's now plug those locations into the distance calculator and see what answer it gives us. So here we have the Jeppesen chart with the two waypoints showing a distance of 439 nautical miles between them. On aviation charts, the location information is given as degrees, minutes, and decimal minutes. So that is south 28 degrees, 19.1 minutes. For use in our calculator, we need to convert that to a degree number, degrees and decimal degrees. And it's quite straightforward. All you need to do is take this 19.1 minutes and divide by 60. So we go 19.1 divide by 60. That gives us 0.3183 repeater. So we take that 0.318 and add to the 28. And we now have 28.318 degrees south latitude. And that is what we need to use in the calculator. You'll notice I have a minus sign because the calculator requires a negative sign for anything south of the equator and a minus sign for any longitude that is west of the prime meridian. So east longitudes are positive numbers and west longitudes are negative numbers. And we convert the latitude for epmol the same way, 31.8 divided by 60 gives us 0.53. So we add that 0.53 to the end of 30, and our decimal degrees is minus 30, being in the southern hemisphere, 0.530 degrees. Let's put that into the calculator. And here is the calculator with the first location already entered to save a bit of time. Let's now put in the second one, epmol. The latitude is minus 30.530. You will notice when I put in a negative number here, that n will change to s. So we want minus 30.530. And that just confirms that you are in the correct hemisphere. We now want the longitude, which is decimal 65.000. We can just put in 65. That's a positive number, so that W will change to E for east. And the distance is 439 nautical miles, as we would expect based on a globe. So we have now confirmed once again that the distance between waypoints on a real aviation flight chart are in fact calculated for a ball. As you have just seen, we have now confirmed that real aircraft flight plan distances and the distances between waypoints depicted on an aviation chart are in fact calculated for a globe. It is one formula that can be used all over the Earth. Now this is something that I have been asking flat earthers for more than 2 years. In fact, there is my video produced in December 2016, a friendly challenge to all flat earth believers. It was simply to produce a flight plan from Sydney, Australia to Tahiti based on a flat earth and providing accurate waypoints and coordinates. More than 2 years later, almost 100,000 views, and not one flat earther is capable of answering this challenge. In fact, after more than 2 years of asking every flat earther I encounter to show me a flight plan based on a flat earth, I have realized this is a checkmate move because none of them can do it. So if you're chatting to a flat earther and you want to checkmate them with one comment, ask them to produce a real flight plan that can be used in an aircraft based on their flat earth between Sydney, Australia and Tahiti, with a waypoint every 500 miles, the total distance, tracks and distances between each waypoint, and accurate waypoint coordinates. Not one of them will be able to do that. The result will be one of the following. They will give you excuses. They will run away in silence. They will respond with insults, or they will attempt to change the subject. But not one of them will produce that very simple flight plan. So what's the problem, flat earthers? After more than 2 years, not one of you is capable of producing a real flight plan. Now that's really embarrassing, guys, because I can do this in less than 5 minutes. In fact, there are plenty of people who subscribe to my channel who are not pilots who are capable of producing this flight plan based on a globe in a very short space of time. So why can't you do it for a flat Earth?